All right, so 3, 4 was your equations. Remember, they're either going to be exponential or they're going to be log. If I look at number 1, this is my exponential one. There were 2 types of exponential. Can I get the basis to be the same or not, which is this case? When that's the case, we're going to isolate the exponential term, and then we're going to ln both sides. So for this one, I'm going to add the 3. I get 2 to the ex equals 13. I want to divide by 2. If it went in evenly, obviously I divide it in, but it doesn't. So I'm actually going to leave it as 13 over 2. If you wanted to make that a decimal, because this is an exact decimal, like I could have made that 6.5, but if it was a rounded decimal, you would not want to do that. You want to keep it exact. So now from here, I'm going to ln both sides of the equation. Ln of e cancels and leaves you just x. And in your calculator, you're going to carefully make sure that 13 over 2 is in the parentheses and you're not closing them after the 13. So I do the ln of 13 divided by 2, and you should get 1.8718. So 1.872 is what we're going to round to. You can check this one, especially with the calculator. You can check all of these, but you don't have to because this one didn't start with a log. The ones we have to check start with logs. So if you go to 2, I obviously have a log equation here. There's only one log on one side, so I'm going to convert this to exponential. The base in the log is 10. 10's going to come over, pick up the 2. 10 squared would be 100 equals 4x, and then divide both sides by 4, and x is 25. Notice I didn't use a calculator that time, so remember your test is going to be part calculator and part without. There's actually more with calculator this time than without, but the graphing is without and all that stuff. So that could be on the part that does not have the calculator. Number 3 has, oh, and I want to check it, right? So I want to go and make sure that this can get plugged back in here, and what's next to the log does not become 0 or negative. 25 times 4 is going to stay positive, so we're fine. Number 3 has more than one log on one side of the equation, so we're going to condense that side. When I condense addition, it becomes what? Good. So this would be log base 3 of 5 times x plus 2 equals log base 3 of x plus 6. We've got log base 3 on either side of the equal sign, so this is my 1-to-1. I'm going to ignore the log base 3 and set what's left equal to each other. I'm going to distribute the 5. I'm going to subtract the x. 4x plus 10 equals 6. Subtract the 10. 4x equals negative 4. Divide both sides by 4. And x equals negative 1. Yep.
On a question where it just says to condense, could you leave it as, like, let's say, for example, you didn't leave the log at 3, 5, and then...
Like you didn't distribute it?
Like you distributed it already. Like instead of after, like when you condense it, instead
Yeah.
of leaving it 5 and then in parentheses x plus 2, you just...
It's fine. If it was just condensing, I would take either one of those.
All right.
Yeah. All right, but remember we have to check these because there was a log initially. I have a negative 1. I have to plug it in everywhere. There's an x and simplify what's next to that log. So the negative 1 by itself, it had been log base 3 of x. I couldn't keep it. But negative 1 plus 6 becomes 5, so that's fine. And negative 1 plus 2 becomes 1. That is also okay. So I get to keep that answer. Whereas if my initial question had a log of x in it, I would not have been able to keep that answer. Before we get into the review, any questions on the homework? Okay. All right, so this is going to take you through 3.1 to 3.4. I actually have your quizzes to give back to you, too, if we've got time at the end. If not, I'll get them back to you Monday. But the quiz covered 3.1 to 3.3 without the calculator. So what the quiz covered, you will see again, are your graphs. You're going to get one graph exponential, one graph of log. The difference is this time they can be without the calculator or they can be ln's and e's with the calculator. So just be prepared for both kinds. Your exponential functions, within those, you could see ones in which we're graphing. You could see your word problem ones. Like here's an exponential function. There was something like that in the homework and then it asks you like bacteria growth or decay or something like that. And then it asks you to find a specific spot. So you're plugging values in. And then you could see your interest problems, which is your A equals P times 1 plus R over N to the NT. Or continuous pert A equals P times E to the RT. These are equations you will not be given and you do have to know. So you want to make sure that you know those without being given them. For the graphs, and again, we did this on the quiz, but as a reminder, you're going to get asked to find the horizontal asymptote, you're going to get asked to find the y-intercept, and you're going to ask to find, and then you're going to be asked to graph it, so you'll get a t-chart. Remember that your horizontal asymptote is based on the vertical shift. So in this case, if this said f of x equals 3x plus 2 is my vertical shift up 2. So my y, or my horizontal asymptote would be y equals 2 in that case. If it was just like f of x equals 3 to the x and there is no vertical shift, then my horizontal asymptote is at y equals 0. Your y-intercept you'd be able to find from the center point on your t-chart if you do it in the right order. And then remember, domain for these is all real numbers. And the range is also going to be based on your vertical shift. So the vertical shift to positive infinity. If it's pointing up, if it was pointing down, it'd be negative infinity. So if it's increasing, then it's that. If it was going down, then it would be negative infinity to the vertical shift. But you should also be able to read that from your graph. Questions on that? Omar, stay with us. All right, then 3-2 was your log functions. Again, we had stuff that was mental math that did not require a calculator. Your graphs that did not require a calculator. But you could also get ln graphs in which you would need your calculator. So simplifying logs without the calculator looks stuff like this. Okay, this is like your quick mental math. What would log base 3 of 1 be? 2. Good. What is log base 3 of 3? 1. Log base 3 of 3 to the 5th. Good. Log base 3 to the log base 3 of 1/3. Good. Log ln of e to the 3rd. 3. E to the ln 4. 4. 3 log base 3 of 4. 4. Good. When we graph logs, which you did on your quiz, remember your vertical, this time it's going to have a vertical asymptote. And it is based on the horizontal shift, which happens inside the parentheses. So if I had f of x equals log base 2 of x plus, well, the example that's here would be like a plus nothing because the vertical asymptote is at 0. This vertical asymptote would be x equals 0. If I shifted this and my parentheses, let's say we went to the right, so negative 2. My horizontal or vertical asymptote is going to shift to 2, and my log would point to the right that way. I would find my vertical asymptote by setting the parentheses equal to 0. So my vertical asymptote would be x equals 2. That horizontal shift also affects your domain. Your domain is going to be your horizontal shift to positive infinity. Your range is negative infinity to positive infinity. You'd be able to find your x-intercept from the middle point on your t-chart. And again, remember you could graph something like f of x equals ln of x minus 2. In a case like that, you'd get given your calculator. It would ask you to fill out the t-chart. You would plug in for 1, negative 1s, whatever, or use your chart. You can actually use your chart if you're given your calculator. Your vertical asymptote would be at x equals 2. Your domain would be 2 to positive infinity. Your range would be all real numbers. So again, you could get given your graphs 2 ways. Without a calculator, with a normal base, or a normal base on the log, or with a calculator, with an ln or an e as a base. Questions on any of that? Okay, then came 3.3, which was the properties of logs, condensing and expanding. All of that was on your quiz. If it's multiplication and you expand, it becomes addition. If it's division, you expand, it becomes subtraction. If there's an exponent, it bumps to the front. And vice versa. If I was on the right-hand side and I'm condensing, so if I started with an expansion, it's positive, I go to multiplication. Negative, I go to division. And if there was a number on the front, it would get bumped to the back. On the quiz, you did change a base by setting up the ratio, didn't actually find the decimal value. Now you will go to the next part, which would be finding the actual decimal value. So this would be log base 2 over log base 5, or ln of 2 over ln of 5. And then you would actually take it to the next step and get your decimal. On that one, be really careful and make sure you close your parentheses after the 2. This would be 0.4301, 06, which becomes 1. So everybody, God bless you. I think everybody got the ratio question right on the test. I mean, the quiz. Just make sure you'd also know how to use that. Plug that into the calculator. And then we finished with yesterday's and where we started the day, solving exponential and log equations. So with exponential, there's two types, the one-to-one or the exponential, where you can't change the base to be the same thing. So something like on the left, we're going to change it to be the same base. 8 would be 2 to the third, and then x would equal 3. On the right, you'd have to isolate the e or the base, which I'll get to the next one. You'd have to isolate it and then ln both sides. So I'd divide by 2. I'd get e to the x equals 11 over 2, and then I'm going to ln both sides. And x would equal ln 11 over 2. Which is 1.7047, so 1.705. And then the 5 to the x equals 4. We cannot change these to have the same base, so we're going to ln both sides of the equation. In this case, the ln 5 doesn't cancel out, but the x bumps to the front. And then I would divide both sides by ln 5. This time again, you have to close the parentheses after the 4. So ln 4, close the parentheses, divided by ln 5. 0.861. Questions on that one? All right, and then all the logs equations. So remember, these are the ones we have to check. If it starts with a log or an ln in the initial equation, you have to check them. The first three, or the first two that are there, are ones in which you have a single log or ln. For these, we convert to exponential. So this would be log base 10, 10 would pick up the 2, and x would be 100. ln of x would be equals 2 would be log base e of x equals 2. And again, only one log converts to exponential. And e squared is 7.389. If there's one log or ln on both sides of the equation, you use your one-to-one property there. So like an ln of x equals ln of 2x plus 3, something like that. I could say x equals 2x plus 3. Subtract the 2x. Negative x equals positive 3. So x equals negative 3. And then these are the ones you'd have to check. So if I plug back in a negative 3 here, I cannot use it. I cannot find ln of a negative number, and this would be a no solution scenario. And then the last kind is if there's multiple logs on either one side of the equation or both sides of the equation. For these, we're going to condense and then either convert to exponential or condense and use the one-to-one. So on the left-hand side, I get log of x plus log of x plus 2. This plus means multiplication. Once I condense, you're either going to only have one log, so you're going to convert to exponential, or you're going to have the one-to-one where it's on both sides. In this case, I only have one. This would be log base 10. 10 to the second would be 100. Equals, I would distribute this, x squared plus 2x. 0 equals x squared plus 2x minus 100. I don't know why I picked this number. It would either be factorable, okay? I guess you could use the quadratic in this case. It should be factorable. So you'd be looking for factors of negative 100 that sum to 2, which, I mean, that sum to, yeah, negative 100 that sum to 2, which does not exist. It would not be factorable. You'd have to use the quadratic. But let's say our number wasn't 2. Let's say, 25 and 4. So it could be like 21. If that was the case, then it would be x plus 24 and x minus, what, 24? My brain's not working. 25, x minus 4. And then I'd get negative 25 and positive 4, and you'd have to check them both. And negative 25 would not work. So you would only keep the 4. And then on the right-hand side, same start, you have to condense. When we condense, it's a minus this time, which means it'd be log of x over x plus 2 equals log of 2. And now there's a log on either side of the equal sign, so we use the one-to-one. X over x plus 2 would equal 2. I'd multiply by x plus 2 on both sides. X equals 2x plus 4. Subtract the 2x. Negative x equals 4, so x equals negative 4. And again, we'd have to check. Negative 4 when plugged into here or here doesn't work, so it would get eliminated and it would be no solution. Questions on anything test related? I think there's 18 questions. The graphs have multiple parts, so those will count for a little bit more. Again, it's Tuesday. So Monday we'll review again. I posted your review. My suggestion is to do it over the weekend so you can come in with questions on Monday and not cram in